Okay, first time the charm. Maybe if this will work. So, if I go to my YouTube channel, will it say I am live? Maybe. Maybe. I don't know. Oh, it is working on my start page. Yay. Okay, cool. So, I will eat some food and then I'll start doing some Godot development. I haven't learned that much as of right now. I've just tried making a little third-person controller, but I'm not familiar with anything like UI and stuff, or how this scripting will work. For example, I don't like that this variable needs to be so big, but right now I have just accepted how it is. But I do need some documentation of Godot. I really want to make some prototype UI. So yeah. So Godot has some docs, right? And I'm probably need to make a new project if I'm going to check all of this out. But yeah, I am going to check on all of this manual stuff right here. It will take some time. Right now I need to learn about how animation is made. I also need to check out the inputs, not networking, maybe some physics, rendering. Scripting is probably pretty important. I don't know. It'll probably come natural to me as I go on. Like every single variable is called var, and then we can define constants by just using const. We don't need to use a var. And okay, this is how enums are defined. That's pretty cool. Only thing, I am a big fan of using curly brackets, but GD scripts wants to do indentation with tabs. I don't really like that, but it is how it is. Maybe I'll get used to it. There's also some shader things. The documentation seems pretty good, so I'll probably just use the getting started for the 3D, since that's what I'm going to do. And oh, canvas layers with UI, cool. So we have the scene to review port scene and canvas layer with the heart. Okay, cool. And can I check how it works? That will be pretty nice. Canvas pass, local pass, screen coordinates. Do I need to set all of this up myself? That's kind of annoying. Oh, introduction. That's rendering. 2D lights. Is this 2D? Cool. But the 2D lighting is better than it is in Unity. That's for sure. Yeah, it's fine. Canvas layers. That's how do I set this up? Canvas item. So the canvas has an object. Well, I need to play around with this. But yeah, I'll focus on eating right now. I make pork chops with rice and mushroom cream sauce. So yeah. Hmm. Yeah, I'll probably make a new project doing the getting started for 3D. Yeah. Oh, will I give some template assets? That's cool. Yeah. Or score on replay. So I will set up UI. Okay, cool. So I will learn about UI with doing this. Okay, cool. Yeah. So that's what I'll do. Okay, and this is popping out. Oh shit, it works. Okay, cool. Yeah. Damn. Save is the project of me right now. Oh, I need to have a taste of this pork chop. Sure. I got some bone with me. Damn. More bones. Okay. Maybe I should have fucking watched this meat. Okay. Do I have some paper towels? No, I don't. Okay, toilet paper it is. Okay. At least it tastes good. That was annoying. So a small piece of bone in this. Already got 2 pieces in 1 bite. Yeah. I need to finish this quick. Oh yeah. Good thing. The power of RepDev. Just kidding. But on the Unity Twitter. Oh, I got a new bone. On the Unity Twitter. Unity has apologized for this runtime policy. And they said they're making some changes. I do hope they reworded the decision. Because the decision was kind of fucking stupid. Since, especially for mobile games. Because it potentially, Unity could take more than 100% of the revenue. So I'm glad they changed it. I just hope that whatever they're changing it to, they won't take more than like maybe 10% of the revenue. It's not. It is kind of scummy, and also Unity said you don't have to pay the fee for mobile games. Maybe that if you use Iron Source for your ads, but the problem with Iron Source is it had controversy where if you clicked on the ad, it will download malware on your Android and maybe also I think um, iOS, Apple devices, iPhone devices, which is so fucking bad because they don't like this ad platform called AppLovin. It's kind of scummy, but yeah. People still don't seem to have that much faith into Unity. I don't really blame them. Even Apergy is the frog of shame. And they will keep posting this frog of shame until they reverse the policy completely. Damn. Okay, that's cool. Not a bad idea. Yeah. Shit. I am learning so much Godot right now. That's crazy. That was a good piece. Imagine I have like one viewer right now, and that viewer is just watching me fucking eat food. Oh, it is. There's one guy watching. That's crazy. Maybe it's just someone who knows. So I'm speaking English for no fucking reason. That's crazy. Who's in this? Who's watching this? My YouTube says there's one guy watching this. Who is it? Who's the guy watching this? Don't wanna type? Oh, I can check participants. Oh, it's myself, bruh. Bruh. Okay. So I count as myself. So I need to know what guy watching me. Yeah, I can watch myself eat. Oh, that's cursed. That's cursed. Shit. Oh my god. Yeah, I can watch myself eat. Oh my god. Oh, that's cursed. That's cursed. Oh my god. 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 Yeah, I can watch myself.
Oh,
Okay,
that's
this is
cursed.
schizo, this is schizo,
That's
this is
cursed.
schizo.
Oh my god. Oh my god.
Oh my god. That is fucking complete schizophrenic, what the fuck? Oh. Okay, I'm done eating soon. Whew. Okay, it's been 15 minutes and it's just me eating. That's pretty cool. Pretty PogChamp. Okay. Okay, I'm done. Now it's time to get down to business. Ugh. There's some more stuff to me. Yeah. Whew. Okay. Now it is time to learn some Godot. That's pretty cool. Oh yeah. I'll maybe have some goals defined. I don't know if I'm going to go back to Unity fast, especially if actually going to revisit that decision. But if I do like Godot, when I have tried it out a bit, I would like to try and make a small game, maybe, with it. I don't know. Because I don't know the capabilities or how advanced it can be. I mean, since it is open source, I can customize it quite a bit if I want to. But I don't know how much I can customize it. Oh well, I can customize it how much I want, but I don't know how much I'm able to customize it due to my competence and knowledge about game engines. I do have a little bit of knowledge because I am making my own, but it's only in 2D right now. I will make 3D eventually, but not right now. But yeah, I am interested in learning it. But anyway, more importantly, well, I will begin my little learning experience. Yay. Okay, so let's say fuck this project. I am going to go into the Godot documentation, or Godot, or whatever how people pronounce it. I don't really care. So my first 3D game. This first part, you're going to set up the game area. Let's get started by importing the start assets and setting up the game scene. We've prepared the Godot project with 3D models and sound we'll use for this tutorial, linked in the index page. If you haven't done so yet, you can download the archive here. Okay, let's go. Oh my god, that's so ugly. Okay. Do I need to take the source code or the starts? Let me try both. So this has some fonts, it has some art, it has OGG file. What the heck is that? I don't know. What is OGG files? That's the mob. Okay. We have the player. Okay, cool. So I will export I will extract that. Nice. Okay, cool. And what does the sorry say? Once you download it, extract the zip file, open the Go project manager and click import button. Okay. So let's go into projects. Project list. Okay, we go into the project manager. We can import project path. Okay. Please. What does it say? Okay, it's just project. Okay, so I'm just opening a file. In the import pop-up, enter the full path of fresh created dictionary. Scroll to preview start. You can click the browse button. Okay. So it's just where I'm gonna place my project. Okay, cool. I am going to maybe go into here. I have this called Godot games. So that's my first project, right? I didn't want it like this. Git attributes. Do I use Git? What? Okay. I think the first project needs to go into here. So I am just going to take all of you and put you inside here. Okay, cool. And then new game. Wait, what the f Sa. Bruh. Bitch ass. I see you, bitch. Okay. Let's make this a 3D tutorial. Game, sure. Just take on this path. Place it inside here. Oh, it's an import. Okay, so I will take this and control exits. Okay. Oh, so I just do this. I'm stupid. And where's the import? Oh, this is the import file. Ah, I see. So it's not here. Open. Convert full projects. Sure. Okay. I thought this tutorial was in Godot. Was it Godot 4.1 branch? What? Oh, this is not up to date. Pull request, no thank you. Well, it's fine. I don't think I will be that destroyed. So let's try and see if I can work this out. I'll put this on a different window. Okay, now it is set up. It is imported. We start the start project contains an icon and 2 folders, art and fonts, where you'll find the art assets and the music we'll use in the game. Art and the music inside of the arts. Okay, cool. Okay, so the OGG file is a sound file. Okay. There are two 3D models, player.glb and map.glb. Some materials is, what is .glb? I thought it was an object. Am I schizo? Property are you? Properties. GLB, I've never seen that before. I usually use OBJ or FBX. Setting up the playable area. We're going to create a main scene with a plain node as its root in the scene dock. Click add child node. Button is represented by a plus icon in the top left. Okay, I've already checked this out. Okay, but yeah, this is the main scene. So yeah, we'll start by adding a floor to prevent the characters from falling. To create static colliders like floor, wheel ceilings, we can use static body 3D nodes. They require collision shape 3D. Child nodes to define the collision area where the nose is set. Add the static body 2D and then the collision shape 3D, and then rename the static body to ground. Okay. So add child node, static 3D body. And that need a collision shape 3D. Okay. A shape must be provided. Please create the... Okay, so the static body, I can give it a physics material. So, a shape must be provided for the collision shape. Okay, cool. It wants to create a box shape 3D. Isn't there a collider for planes, like in Unity? No? Oh, that's fine. Yeah, I see it doesn't have that. Maybe convex, I don't know. But yeah, let's make a box. So that is the collision shape. Box shape is perfect for flat ground and walls. Its thickness makes it reliable to block even fast movement objects. Fair point. The box wireframe appears in the viewports with 3 orange dots. So these. So they are the edges of the box. Yeah. We can also precisely set the size in the inspector. Oh, can I drag on this? Oh, okay, cool. But I can drag it in the inspector by going to the shape. Can I? Oh, shape. I'm pretty sure I could edit it. Edit. Okay, I can edit the box size like this. Okay, cool. So I'm just gonna follow this page. 60 meters by 60 meters and 2 meters. And now I have a big flat plane. Okay, oh well, not a plane, but a big box. Then I need to have a mesh instance for this ground. Oh. So let's add the mesh instance. So the mesh instance is just a mesh renderer, like in Unity, I guess. And this will be a box mesh. Cool. And I can maybe also edit these properties to match this, I guess. So 60 2 and 60. Would be cool if you could just is there like what is primitive mesh? Okay, well, it could be cool if you could check for the colliders and then it will just set the size to the same as the collision 3D. Or why aren't the collision shape on the mesh instance? Wouldn't that make more sense? Well, I'm just following the tutorial. Not much to do about it. But yeah. So this is the ground. Who is in white? Godot based on the story rating for Godot. Okay. I guess this is someone that's an Godot enthusiast coming with actually facts. And OGG Volpus Audio. Okay, I see. Thank you. So hold down. Okay, so control is grid snapping. And we can move it inside the gizmo. If you can see the. So yeah, here's the select modes. Move mode, rotate, scale, that's cool. Okay, ultimately the ground's transform position to Y needs to be -1. So let's just set it to that. Let's add a directional light. Okay. So far this is just adding stuff on and off. So yeah, I got shadows. Do I have the wrong rotation, or why did it get so dark all of a sudden? Okay, it's just the normal. At this point, your project should look like this. Well, it has. In this picture, it is there's light. Mine legit became darker. Like if I remove this, this legit became more light. Is it because there's no sunlight? Shadow enabled, probably cool enough. Oh, wasn't there this environment thing? Yeah, world environment I need to add before it happened. And it needs to be here. Acquire its environment for it to contain an environment for its camera attributes. Oh, okay. So not yet. I will probably not worry too much about it right now. Oh, there's no rotation on it. Ah, I see. There was no default rotation. How much rotation do I need on it? In Unity, I think the base is 30 on the X. No, -30 maybe. And 60 on the Y. I think this is how Unity does it by default. So it goes kind of like right down. Okay, that's cool. So this is the starting point. This is the first. Set up the game area. Okay, set up the playable area. That's good. Oh, I just set up the game area. Testing. And add the directional light. And that should be good. Okay, so I added up the playable area. So now we need to add the player scene. Okay, so the scene needs to be separate. So in the next 2 lessons we will design the player scene, register custom input action, and code player movement. By the end you'll have a playable character that moves in 8 directions. Okay. Create a new scene by going to the scene menu. Okay. So new scene. Okay, they just removed the old one. Okay. That's fine. And of course CD node. This is the player scene, so I'll probably just call it player scene. Oh no, this is a root node for the player. Oh, so if I remove this, I can add another node, which needs to be the character body 3D. And this is going to be a player. So the player is a separate scene. That's weird. So the character body 3D is the root node. Name the character body 3D to player. Character bodies are complementary to the area and rigid bodies used in the 2D game tutorial. Like rigid bodies, they can move and collide with the environment, but instead of being controlled with the physics engine, you dictate that movement. Okay, so it's kind of like kinematic or the character controller in Unity. You will see how we use the node's unique features when we code the jump and squash mechanic. Alright. There is also a physics node I can use if I want to add physics. Okay, but I'm not gonna worry about that right now. So for now we're going to, oh, I'm probably gonna need to turn on the lights. I also got someone giving me a notification. Oh, it's this bitch ass. Oh, you're another Unity refugee? Okay, so you've just been researching this, so you've been using it for like 8 hours? Well, that's more than me. I am I've been using Unity for like 7 years, and I haven't really tried anything else. I tried Unreal, that was pretty nice, but I only have a 1/4 terabyte on my laptop, so I don't want to use like 60 gigabyte to have a game engine on it. So that's like my reason for never using Unreal. So I've just gotten used to Unity. Okay, let's see. So add a node 3D as a child of the player, I name it pivot. Okay, cool. Just a normal node 3D. And call it pivots. And then in the file system, expand our folder and drag and drop the player model. Okay. Where the fuck is it? This one. It has a dumb logo for a model, but I'll accept it. So this is the player. Okay. So Does this it doesn't say what kind of component this is, so it doesn't add a component by default. It just knows what it is. Okay. Well, this is the character. 3D scene data based on the open source GLTF specification. Okay, so it's an open source object file specification. Where model and perform alternative to a proprietary format like FPX, which Godot also supports. To produce these files, we designed the model in Blender and exported to GLTF. Okay, cool. With all kinds of physics nodes, we need a collision shape for our character to collide with the environment. Select the player node again and select the collision shape, and we will add a sphere shape. Okay. Collision shape. Sphere. Is this the... Okay, it's pretty small. I see. Piece to be below the character. Well, it's really small. Okay, Anne M. White, how long have you been using Unity before you tried out Godot? Move up the shape so the button roughly aligns with the grid's plane. Well, I need to edit your size right now. You're too small. One? Okay. Maybe the default value. Oh, my speed has about 1.8 meters. Okay. 1.8. And it is below, so we need to upsize it a little bit. So the transform, like I really like precise. I'm only gonna make this clarity just a little bit smaller, maybe 0.7, and okay, I just around match it. I mean, it doesn't really matter. It's not like I'm gonna make a big game with this. This is just a tutorial. But yeah, it's cool. But we need to create input actions. Yay. Okay, so we go into projects, project settings. Okay, this is kind of like Unity. And we have the input map. Click on the input map, click on the top bar. Okay, and we need to create 5 new actions. Okay, so this is kind of like Unity's input system, like the new one, not the legacy one, where you need to make action maps. So I like that because I do like that quite a lot. So it has a lot of built-ins, probably that's maybe useful, but we need to add our own ones. So move underscore left. move right, move up, move down, and jump. Okay. And we need to assign a key to every single one of them. So the left is going to be A, right D, W, S, space. So now I have inputted the type of movement. I can also add joysticks, but I don't own a joystick controller, so I probably wouldn't worry about that. But I do get the gist of it. I have done this with Unity, so it's probably similar to how it works. So yeah, okay. You can use the menu to label any group of keys and buttons. Okay. So now that's good. Okay, now it's time to move the player with code. Yay. So moving the player with code, we can right click the player and select the attached scripts. Set the template to empty before pressing the create button. Attach script. So node empty. Object empty. And this will be good. Okay, so I will click create, and now I have made the script. So I guess the I see. So when we use, I'm using the C# code as a reference to how this works. So this extends right here. Basically, it just says that we are making our own class, which is the player script, right? But it's inherent to base functionality for the character body 3D. So in that theory, we should be able to just access all of the properties of this character body 3D. So that's a good thing to know. So every single script we make is just going to be an inheritance of the base node class. So that's pretty cool. So yeah, let's make the code. So comments, I'm just going to write it down as it is. So this is a comment. I just need to be familiar with the syntax. Moves in meters per second. That's what I want. Meters per second. Isn't 14 meters per second kind of fast? And then it has this export value called var, which is the speed, which is equals to 14. And then it has something called the downward acceleration. Okay. So the downward acceleration when in the air in meters per second squared. So meters per second squared? Is that why the tutorial says it's going to equal to 75? Isn't there a math library? That's kinda weird. Okay, and when I look at this documentation, this add export it looks like it will make it so I can edit the variables in maybe the inspector instead of using them per instead of editing only in the script. This is just simply an initializer. So let's see how that works. Resources, new folder, maybe scripts, and save it down there. Okay, cool. So if I edit you, can I? Okay, I don't know how this works. Okay, it doesn't really matter. I'll maybe figure it out later on. But yeah. So so the target will also be combines the direction. Okay, this is exactly like in Unity. The values are quite different from the 2D code because this is just a meter, while in 2D, 1000 units, pixels, may only correspond to half your screen's width. In 3D, it's a kilometer. Wait, so in 2D you use pixels as defined length? That's kind of weird. Stupid even. Maybe I'm misunderstanding, but that just sounds stupid. Okay, but now we need to make an override function. And Godot has defined their own overrides. So this is the one called physics process delta. And we create a local variable to store the input direction. So that's cool. Go bar direction. Maybe makes equal to 3.0, and we check for each move inputs and update direction accordingly. Okay. So we check for each move input and update the direction accordingly. Yes, okay, so if I don't really like this syntax, it reminds me too much of either Lua or Python. I don't really like that syntax, but it's fine. So input dot is action pressed, and okay, I do like this. So it does has a combo box for all the custom input access we made. In Unity, you just need to remove their names. So I do really like this. Equals to 1, and then I'm just going to copy paste all of this. So okay. So I move left, and then this is going to be minus equals 1. Then we move down, well, back technically, but it doesn't really matter. So notice how we're working with vectors x and zx. In 3D, the x-axis plane is the ground plane. Yeah, I know. Okay. So this is what I don't like. The z-axis in Godot is flipped. So backwards is actually positive z, while forward is minus z. Why? I don't like that at all. I think it's stupid, but I guess it's just something I need to just deal with. Yeah, it's stupid. So going forward, I need to minus the z position. So here we're going to make all the calculations using physics process. Okay, this virtual function, like process. It allows you to move the node every frame, but it's designed specifically for physics related code. like moving kinematic or rigid body. Okay, so in Unity there's the update and the fixed update. So the fixes process is probably just a fixed update of the Godot engine style. That's cool. So we start by initializing the direction. Okay, we have to do that, and then we check the inputs correspondingly. If you use W and D simultaneously, the vector will have a length of 1.4. Yeah, because we add 2, and then if you use Pythagoras theorem, then 1 plus 1 squared is 1.4. So we need to normalize it. So we can just call the normalize key. So in the code, if the direction is not equals to vector3.0, which means that we are moving, we'll first have to normalize the direction, and after that we can use the pivot.lookAt function, which will take our position of probably this character body right here and plus it with the direction corresponding to the up vector. So let's try and do that. So the if, I was just about to make parentheses, but we don't do that in Godot apparently. Like fuck it. But yeah, we make the if statement and we say then we need to make it equals to itself normalized because we don't want it to go fast, and then we can reference the child pivot by using the $sign right here. So pivot dot look at. There's also this function called look at from position. I'll use that just to see if it works, because it already has the position vector phrase, so we just need the target, which is the direction. So wait, the position is just the position here, and then this is the target, which is the direction. Okay, maybe just use the normal dot look at. Yeah, so the normal look at just has the target, which is the position plus direction. So we use the position plus direction corresponding to the vector3.up. Oh, and it already has a default initializer on the up axis, so I don't need to write the last spot. So that's good to know, because it has a default initializer right here. Wait, does the lookat from position have the same? No. So I'll use this. So that's cool. A lookat function, this takes position in space to look at in the global coordinates. Yeah. So the lookat function makes this child pivot look at a coordinate in time and space. So we take the current position of the pivot and we just plus it with the direction. So it will rotate along the up axis, so till it will look in the direction where the point will be in space. Sus. I heard someone. Someone texted me. Okay. Oh shit, people put in our Lord and Savior open source engine. Yeah. It's like fixed update Unity. Yeah, I know. There's also, yeah, I know. Delta, yeah, I know. Okay. You can use input.get vector. Okay. That one is useful. Thank you, Mr. M. That one's actually useful. I will probably look that up. Oh, we can just try it right now. So input dot get vector, and then I can use the move the left, right, up, down. Okay. So let's see. What the hell? Oh yeah. So the move left. So but this gives me a vector 2. Oh well, it can work. It can work. It's just that I want this a vector 3. Because since I'm working with 3D, it will make sense to use dot .z instead of dot .y. Oh, is there a 3D version? Okay, let's just try. Yeah, okay, so negative, so that's up, down. Also need to define the dead zone. Okay, so this is vector 2. This is useful for 2D, but not 3D, so I'm probably not gonna use that. Because I like to keep it clean. But yeah, okay, this is cool. So yeah, I have normalized my vector. I made it look at the direction on the point in space. Now I need to move it. So now it is time to move stuff. Yeah. Okay. So okay, this is basically just the character control from Unity. There is also a bool function for is on floor, which is basically just is grounded. So first I'm gonna make the ground velocity, which is pretty easy because we already defined it. So we just take the target velocity dot x, makes it equals to the direction. But oh well, maybe we can use it anyway because we're putting inside the target's velocity anyway. So maybe I could use that. Oh, it's nice because then I don't need to have 4 if statements because those are annoying. Yeah. Okay, then never mind, Mr. M, you're a genius. So let's have this direction be equals to vector2.0, and instead of doing this, we will make the direction be equals to the inputs dot get vector. I already min-maxing this. I'm just following the tutorial. But okay, so we need to go down to negative x, so let's move left. Then we have the positive x, so let's move right. Move right. And the forward, no, the back, the negation is. See, this is what I don't like. So now I'm at the point where I'm at the negative y, and the negative y is the up, which I really hate, but it is how it is. And this is the move down, and I am pretty sure the dead zone is if I can get a better look at it, I can't. The dead zone probably has a default initializer of 0.5, so I'll say this is fine, and then we'll just normalize it like usual, and we will set. So we will change the order a little bit. So we will update the target velocity before we go into the look at direction. This also kind of makes sense. So I think this is fine. So we do this, and then we do all that. So when we set the dot y equals to the dot z, you know, and then we just go back to this. I'm min-maxing. I will just do this. Screw it. Direction equals to vector3.0 and the target velocity. Okay, cool. So that is my thing which I am going to do. This is my little min-maxing because I don't like the for if statements. Okay, yeah, and I need to time this by my speed variables, so that's good. And yeah, okay, now we go back. So now we need to check on the gravity, so the vertical velocity. So if we're not on the floor, we will set our target velocity being equals to the target velocity of y minus the fall acceleration times delta. So that seems pretty good. I don't know about 75. I don't really know if this is a good function, but ayo, it is fine. So if not, it's on floor. Oh, we can also check for ceiling. Okay, that's cool. But if we're not on floor, we will take the target velocity dot y, and why don't we just minus equals it with the instead of doing this line, we will just minus equal it with this line right here. This looks more clean in my opinion. I probably spelled it wrong. I did. So yeah, I think this looks cleaner. And then after we have done all that, we can set the velocity. But now we're gonna actually move the character by setting the velocity of our 3D our character body 3D. It's equals to the target velocity. And there what is this move and collide? Okay, so this is the different types of movement. So there's move towards. So move toward is probably we're gonna move towards a specific point in time, and move and slide is just maybe the default. There's the move and collide. Well, let's just do this one since this seems to be the default. And yeah. So that was the whole script. Someone texted me again. But I missed him. Respectable for watching One Piece. Was pretty nice. So we can test the player movement. So yeah. Oh. So this is the player. Oh, the thing I saved in the scripts was not the play. It was this was the scene, not the player. Okay, I see. Then let me just rename this to scenes then. Because yeah. And this is the main going into scenes. Okay, cool. So now it is as expected. So we can test the player movement. We're going to put a player inside the main scene. To do so, we need to instantiate the player and then add a camera. Unlike in 2D, in 3D you won't see anything if your viewport doesn't have a camera pointing at something. Wait, so in 2D you don't need a camera? Okay, nice. So save your player scene, open the main scene. You can click on the main tab. If close file system, okay. To instantiate the player, right click on the main node and add instance child scene. Okay, so child scene, and we can add the player like this. Okay, so a scene can also just define a whole object, and we can have a child of it. Okay, that's kind of unique. So adding a camera, let's add the camera next, like we did with our place pivots. We're going to create a basic rig. Right click the main node and add child nodes. Create something called markers 3D. Marker 3D and call it camera pivot. We're going to see in a bit how this works. And that needs to, and the camera pivot will have the camera node. Okay. Camera 3D, I'll just call it camera. And we can preview the inside. So right now it is inside this little thing right here. We can look at, damn. I'm having multiple, oh. This is, this looks weird. What the hell is this? So in the toolbar right, you can click and have 2 viewports. Okay. And at the bottom view, select your camera 3D. Oh, okay, so it wants me to preview through the camera lens down here at the bottom. At the top you move the camera about 19 units on the Z axis. So the camera, not the camera pivot. Okay, I see. So position. Okay, well, 19 units. That's quite far away. And here is where the magic happens. Select the camera pivot and rotate it minus 45 degrees. What? Yeah, okay. So I don't want this viewport anymore. Go back to 1. And now it tells me to run the scene. Select current. Okay. What? So yeah, okay, it works flawlessly. And if I go out, I'll just fall. That's pretty nice. Okay, cool, cool. Fair enough. So yeah, okay, cool. So that works. Let's got a new camera. If the directions will look blurry, switching to the auto camera to decrease the camera's far out property to lower than sensors at 100. Okay, I don't really care. Why should I care? Because, okay, so it's just in the case where I have my camera set to orthogonal, but that's for 2D view. I'm looking at 3D. So that doesn't really matter. Okay, so what are these 280 errors? Oh, is that because the tag velocity didn't want to work? I don't know. Okay, so when I'm not moving, this gets many errors, but as far as I can see, it's not crashing. So maybe it's the compiler that's fucking up. A vector and direction between node origin and target are aligned. Okay, so their issue is that these are equal to the same, so it doesn't know where to look at. Okay, and that's because this is actually not equal to vector 3.0. Okay, well, it's because we add this, and it's probably don't like it. It probably won't even affect performance because we will only like move to the sides when this has a value. So as a debug, even though this is probably not best practice, this will probably make it so I don't get like 3000 errors, because when it checks the two values, which we know are same. Yeah, see now the debugging is fixed, so now I don't get spammed with so many errors. That's cool. I would like to interpolate the rotation, but so far this is nice. So yeah, that's cool. Yeah, okay. So that's going part to the next tab. Okay, now it's time to set up the enemy, and it has a significant page. Okay. Yeah. Do I have people watching me? No, I don't. I'm just talking to myself. I'm completely fucking schizo. No, my YouTube says 4 people are watching. What? The next tab. That's a lie. Yeah. What are the 4 people watching this? That's a lie. Because when I look at the participants, it says 0. It says it's only me. What? I got a new subscriber? It's Chinese letters? Okay, that's cool. Yeah. Oh, I haven't even touched my my drink. Oof. Someone texted me. Let me check. Oh, it's a cat. Oh, I love cats. Someone sent me snap. Oh my god, it's Mr. Saar. What the hell? He posting picture of me stream. Shit. Piece of shit. Okay. Yeah. Okay. I need to pee. Shit. Oh. Should I take a piss with my mic unmuted? So you can hear the loud water splashes? Oh no, that's cursed. Okay, I'm gonna mute now. Okay, I'm done. Yeah. Okay, so I want to try and see if I can interpolate this before I move forward. I just want to see the capabilities. Like in Unity, there is a lerp function for vectors. So I'm just going to check if target velocity have the same. Oh, it has. Oh, that's so poggies. That's so poggies. Because then I just want to because okay, so here's my idea. So maybe it was stupid to do this, but fuck it. I'm going to commit fully now. So I am going to so this is just going to be the input directions now. Okay, okay. Give me the arrows. Okay, and down here, right? I am going to make a var called the actual direction. So oh yeah. In Godot, they like to use the naming type. We use snake case. So for every new word, we need to make an underscore. It just is how it is. So I'm just going to follow their rules, since I guess that's a good idea. Okay, so this is going to be an actual vector 3.0, right? And we actually going to fill in these gaps, right? So we store the input inside this direction, and then we try to lerp it inside the target velocity. Bro, your spamming Unity is dead in a live stream with like only you and me. I mean, Unity is not totally dead. It will probably be popular anyway because it's big, but people will probably hate on it for a long time. So yeah, it is how it is. I will probably go back to Unity eventually, especially since Unity posted a tweet where they're gonna change their little install fee policy. Either they're going to revert it, which I hope is the best case scenario, or else we're gonna try to compensate for something more reasonable. So yeah. No, well, okay, this is the weight, so this is kind of different from normal interpolation. So because the weight, well, it goes from 0 to 1, and if it's 1, then it's instants. Do I then just say 0.5? And this returns a vector 3, so should I then say, I don't know if this actually changes the value itself, or then is this equals to. I'm just going to set equals to because that's what I think is probably right. And let's see what happens, right? Oh, we also need to plus the direction dot y is is equals to the target velocity to y. See, now I'm already overcomplicating what's happening, but of course we want this to be the same as the lerp. Yeah, I'm probably already on overcomplicate this. I just really want the thing to work right here. So this doesn't want to work right now, and that's because we defined the direction down here. So the input direction needs to be the input direction dot normalized. So that's good. Let's see if this will interpolate everything. I hope it does. If not, it will just spasm out. Okay, see, it's instant when I do this, but it does looks like to have some kind of smoothing when I use when I go sideways. Yeah, right. That's not instant. That's smoothing. So I did something right. So what the fuck? Maybe if I set this down, I will maybe see a bigger difference. It's not really noticeable right now. Okay. Yeah. So that's cool. And actually, I still want my movement to be instant, because now my movement itself is also lerp, which looks cursed, right? And also, it just bloop, 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 flips like this. I don't know if that's how it's supposed to be flipping, but yeah, okay, so I did this correctly. That's good. Yay. But maybe I don't want my target velocity to be interpolated. I probably want my target velocity to be set as normal. So look direction, right? So I'm going to set it like this. I don't even think I need speed for this, actually. I just need the direction. We need the target velocity right here, set, and then we have the look direction. And the look direction is what we're going to interpolate, right? With that lerp. And we're going to lerp it to this velocity with 0.1 weight. I do like the way lerping works in Godot. It's kind of more simple than it is in Unity, but I do prefer the Unity more, because the Unity it's more mathematical and also explains the math quite nice. But it is also cool that you can just set a weight and is how it is. But yeah, okay, so now this is interpolated while the target velocity input is based as normal, like in Unity. So if I run this now, and I'll start my... I forgot to add the speed. So that's cool. See, that's cool. So the input is back to speed right now. But why is the look direction lerp is it looks kind of bad. So why is that? Because it worked right before, right? Could it be something to do with this? No, right? Oh, it's because we redefine it as it doesn't need to be a local variable because we set it to 0 every time. So this needs to be a global variable like this, you know? And now since this is a global variable, now it will work as intended because we don't set it to 0 every frame. Well, not every frame, but in every physics frame. Yeah, so that's more like it. So I think this is okay. And oh, 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 okay. So this is cool. So I went a little bit off script from what the tutorial is, but that's good because that's all a learning experience. So this is kind of more. So this I'm getting more familiar with it as I speak. So this is the target velocity, and this is the look direction. And we take the look direction and interpolate it based on the target velocity and make it pivot look at it in that direction. So this is probably not how I will usually do it. I don't like to use the look at, especially since we use the corresponding. It has a default parameter of using the up axis, but it still kind of flips. I don't really like that. I just want it to go in a circle. I don't want it to like if we say this is how it should rotate, right? Like with my hand, it did look like at some point it did this, and it shouldn't do that. I don't know how to fix it really because I'm not familiar with this. Look at the function 100%. Maybe I can avoid it by setting one of the axes to 0, and it won't flip like that. But so far, I think it is fine. It can always be polished in the future. Well, this is just a tutorial. I'll probably move on past it so far. I will make my own game eventually. But okay, so this is cool. Um, so designing the mob scene. Yeah. So what am I going to do? Well, mm, so let me get a drink. This is slowly clicking for me, I feel like. So that's good. Um, so, uh, yeah, let's create a new mob. So we use the same format where we create a new scene, and this scene will have the mob. I think it's kind of weird how scenes are in Godot. Like, usually in game engines, a scene is like a level, but you can make child scenes inside of this. So a scene can be more like just well, a scene is defined by just having some data with some entities in it, and in this case, the entities are nodes in Godot, so it just loads them all in as a scene. I do think it's personally, I think it's kind of weird, but I can see how it would be kind of cool because in this scene player we have these definitions right here, which most likely aren't really necessary, and when we go to the main we will just have the player kind of like as a normal node. So it is cool, I guess, but I don't know how familiar I will be with this format. Also, since scripts are assigned per node, like some form of customizable metadata, because, well, it's not a customizable metadata. We override the base nodes with its own attachment script. So in that case, I will make an attach script to the directional light 3D, and I will make my own custom directional light 3D node because I've attached the script on it that changes it. It's not as direct, but it is a cool format. I guess it's because it's more data oriented than the object oriented. And object oriented is more easy to understand, while data oriented can sometimes be kind of hard to wrap your head around. But as far as I can see, Godot has a good way of visualizing it, so I think it's fine. But yeah, okay, let's make this new scene right here for not like that. New scene, and it's going to be 3D. No, can I just do the same? Yeah, I need a character body 3D again. And this is going to be the mob. My fingers hurt. And we'll just attach a normal node to it called pivot. Blech. Pivots. And I'll drag and drop the mob right here. Yeah, okay, so this is how it looks like. This needs to go down here. What problem is it? Oh, it's just because we don't have a collision shape yet. We'll have it in a bit. This is the character. And we need a collision shape. Don't I just use the same, since it's the same mesh as the player, just different color? I guess I'm just going to have the same kind of values as the player. So I'm just going to have this sphere, and I'm going to edit it like a 0.7, and I'm just going to take the thing right here, transform. So copy, paste, pog. And did this work? No. Okay. That's better. Why you like that is because this one is further down. No. No. So why? Well, doesn't matter. Anyway, it is set kind of correctly. Nothing too crazy. We're gonna save this mob scene just so we have a place. Oh, this is going to be a box shape. Okay, never mind. Not a sphere, I guess. Well, then I'll edit this correctly. Yeah, these points are kind of useful. This is probably too bloggy. Fair, and yeah. Removing monsters off screen. Okay. So we're going to spawn monsters at regular time intervals in the game load. If we're not careful, the count could increase to infinity. Okay, based. And we don't want that. Each mob instance has both memory and a processing power. Well, have both a memory and a processing cost. And we don't want to pay it for it when the mob is outside of the screen. When the monster leaves the screen, we don't need it anymore, so we should delete it. Godot has a node that detects when objects leave the screen. called visible on screen notifier, and we're going to use it to destroy our mobs. Okay. So as soon as it leaves the screen, will it? So if will it delete the mob entirely, or will it just turn off the draw calls for it? Well, I'll maybe find out eventually. So this is called the visibility on visible on screen notifier. This logo right here. So add a channel node and a box. Pink this time appears. This box completely leaves the screen. The node will emit a signal, like okay. So yeah. What the hell? Oh, this makes it smaller. Yeah, I'm not gonna follow this line like 100%. It's just a rough sketch. Okay. Oh, this needs to be bigger when the object itself. Okay, I see. Not like that. Like this, and like this, and like that, and this. No. 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 Yeah. Okay, now it's completely covered. Coding the mob's movements. Okay, see. So we need to attach a script. Mob GD. I do kind of want to make an inventory in Godot and see how it will work. We'll probably have a private node make follow the inventory. I could also make the inventory as a separate scene and then add it on as a child scene if that's how it seems to work. But I'll probably not worry too much about it right now. Okay, so this is the different scripts. Yeah. So yeah, I don't want to write comments out like this now. So we're gonna make a variable for the minimum speed, which is equals to 10. And I'm gonna make another one for the max speed, which is going to be equals to 18. And then we have the physics process. Bonk. Physics process delta. And we have move and slide. So similar to the player, we use the mob everything by calling the move and slide. This time we don't update the velocity every frame. We want the monster to move at a constant speed and leave the screen even if it were to hit an obstacle. We need to define another function to calculate the character body 3D's dot velocity. This function will turn the monster towards the player and randomize both its angle of motion and its velocity. Well, just towards the player, we just take the point of the player to compare it to. So we need to make a connective vector. So we need to minus both positions to get the direction from the enemy to the player, and then we just maybe rotate it a little bit to make it go into another direction, and then we just make it walk forward. Okay, so let's see how they do it. So okay, so this is the func initialize. So this function will be called from the main scene initialize. Okay, I see. So by a start position relative to the player position. This function will take a start position, the mob spawn position, and the player's position as its arguments. We position the mob at start position and turn it towards the player using the look at from position method. And randomize that angle by rotating it a random amount around the x-axis below the randf range. Outputs a random value between minus pi divided by 4 in radians and pi divided by 4 in radians. So that's cool. So yeah, okay. So we need to use this func initialize. Func. Oh, this function will be called from the main scene. Okay, so it still needs to be inside of the yeah, it still needs to be inside the mob script. Okay, cool. I don't want to be confused. So let's initialize. Oh, there is no initialize. Oh, it's because it's the custom function. So we have the initialize where we take a start position and we don't need to define it. Okay, and a player position. And we take the look at from position and we use the start position as a reference to the player position. And this is already by default up, so we don't need to do that. And then we just rotate the eye by a randf function, a random float range. And this is going to be minus pi divided by 4 and pi divided by 4. So this is beautiful. Okay, so this is an initialized function from the mob. So when we go into the main scene and we eventually spawn a little mob scene thing, right? A little mob object, we'll run the initialize from the start position where it'll spawn, and we have a reference to a player with their position, and then we will look at it and just rotate a little bit between minus pi divided by 4 by pi divided by 4. So that's good. But yeah, we also need to set the speed. So let's say let's make a variable for the random speed and use an index range and an integer range for random, and we just put in the min speed and the max speed. And that's all good. Yeah. Okay. Now we just take the velocity, which is equals to vector 3 dot forwards times the random speed. And then we take the velocity velocity is equals to velocity dot rotated up, so vector 3 dot up. Okay, so this is something I haven't seen before, so this is probably how you usually do it in Godot. So the problem with this that in Unity you can't just set the vector 3 dot forward as the normal direction, because that's the global forward vector. It doesn't take rotation into the character's rotation into consideration. But I guess this is what this do, because it takes the rotated, it takes the velocity and rotated along the up axis based on the character's actual rotation, so it kind of aligns it into the direction we want it. So that's good to know. This is kind of Godot specific trick. This is not how you usually do in Unity. We just say the transform the forward equals to we just say transform the forward times random speed in Unity, but here we need to have an extra line to rotate it. But yeah, that's cool enough. So I'm kind of tired. But yeah, we need something for leaving the screen. So we'll have to destroy the mob when it leaves the screen. So we need to have this component right here and somehow connect it to the mob. I don't know how to do that, but let's hope this tutorial can tell me. Yay. So we could go, oh, so this is the node specific things. Oh, so here we have the, script change. Okay, I see. So we have something here on screen as it is. So this is the event for this specific node component. So that's good. Okay, so this is basically the different components. We have the object component, the node component in the 3D, and then we actually have the visible on-screen notifier. Okay, that's cool. That's good to know. So every node has these three basic components. That's good to know. Okay. Well, anyway, we have this screen exited, and what do we do here? Okay, cool. So we need to align it to the mob. So connect the signal to the mob, like as I have right here, and then I just click connect. This will take you back to the script editor and add a new function for you called onVisible on-screen notifier 3D screen exited. Okay, so this is the override event function and called the query3 method. And the Q3, this function destroys the instance it's called on. Okay, cool. So that's good. So here we can use the Q3. And Q3 means that is the same as destroying the object. Okay. So now this monster will be ready to enter the game, and now I have the full script. Okay, that's cool. So now it's time to spawn the monster. So I'll just save this, go back into main, and before we're drawing the path, we're going to change the game resolution. Yeah, that would be nice. We do that by we go to general, and is there a display window? We're going to set it to 780 by fuck no, I'm going full screen. 1080. mode. Maximized for now. Full screen will be used at some point. Okay, so creating a spawn path. I'm kind of tired. Let me just crack my neck real quick. Oh, someone texted me. Oh, it's about university. Oh, it's greatest common divisor. He's asking for help. Oh. Okay, I'm back. It's probably still just me. How many are watching this actually? Loki. No one. Let's go. Well, that's pretty cool. Well, anyway. Yeah. So, yeah, let's do this. So, we need to, like you did in the game, we're going to sign a path using a path follow 3D node to sample a random location. Okay, so this is a new type of component as I see. So I can add something called a path follow. Path follow 3D. Boom. And it needs to be a child of a path 3D node. Well, that's good to know. So I'm going to delete that. So in 3D though, it's a bit more complicated than to draw a path. We want it to be around the game view, so monsters appear outside of the screen. But if we draw a path, we won't see it from the camera preview. To find the view's limit, we can use some placeholder measures. Your viewport should still be split into two parts with the camera preview button. If that isn't the case, Control 2 to split the view into two, the camera 3D node, and click the preview box. Okay. So annoying. Yeah. So And cylinders. Well, I need to use this follow 3D. So first we have the path 3D, and then this one has the path follow 3D. I don't know what this does. Well, anyway, I'll just delete this. It'll probably work ivory later on. Okay, so adding placeholder cylinders. So let's add placeholder meshes. Add no 3D as a child of the main and name it cylinders. Woohoo! So child node 3D. Let's call this cylinders. We're gonna make and add an instance 3D. Okay. Mesh instance 3D. So this will be a cylinder mesh, yay. And then I'll go to top view. So how do I go to top view? I don't know. By using keypad 7. Okay, like that. And view grid. No. Whoa. How? Use snap. Oh. I will use snap. Where's the U grid? Okay, it's right here. It's probably inside the settings now. Oh, view grid right here. Okay, cool. And so move the cylinder so it's right outside the camera's view in the top left corner. Okay, so I need to see the camera's view. How can I see the camera's view? Oh, like that. Okay, I see. But it's kind of far off, you know. Like it will see everything. So what is the point? Is because it wants it to be orthographic? Oh, it wants it to be orthographic, I see. So if I use the 19 here, it's way more defined now. But no, I don't like this very much. So size 19. What about 12? Sure. So with this, right, I will okay, this looks weird. Oh my god. No. 19. Right. So this is not how it looks like. So this is the view now. Can I see the wireframe on the camera view? That would be pretty nice. Oh, so this one is going to be using the top-down value. I see, I see. So if I take this cylinder right here, take and move it right here, it'll be just outside, right? Not quite. Okay. Like that. Yeah, sure. Okay. So that's what I need to do. So I need to move it out and then I just copy paste. Okay. UB. I'm so lucky. Like that. And then I have this one. So let me check. Okay, one more tick, like that, and then boom, 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 and then it should be all good. Yeah, okay, so it's outside. Select both insert. Yeah, sure. It's a bit hard. We can move. Oh, the mesh is just needed to be inside cylinder, like this. Okay. So screw this one. Screw these ones. And why you complaining? I don't know why you're complaining. P and paste through node path condition. Mesh instance 3D3. Well, it looks good, right? No, yeah, it is. It's not complaining. So okay, we're gonna make all of these. This sphere right here is gonna give it a new material. So where do I give it a new material? I don't know. Maybe I need to edit it. Edits. Where's the material? It's right there. New standard material. Always different kind of materials. So I can also give it a new shader. Okay, cool. But yeah, new shader material. And I can edit that one too. Yeah. Okay. Shit. Oh, I can give it a rim. Enable. I mean, I like this customizability. That's pretty cool. Well, anyway, albedo, making this orange. Yeah, just like that. View one, but yeah. So we can now use the cylinders as guides. Fold them inside the scene dock by clicking the gray area to them. You can also toggle visibility by clicking the eye icon to the cylinder. Add a child node path 3D. Oh, sorry. This is just to visualize. Okay, so I can just add them off. Okay, so add a child node to main node called path3d. Path3d, okay. And click the point tool icon. Oh, oh, right here. So add a point. I can also close curve. So, oh, so add point this, 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 this to this. Close, 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 close. What in the actual fuck? Okay, this sucked. Okay, it's probably because I need to be in top-down view. So let me go back in top-down view, and I'll click add, and then I'm gonna see boom, boom, just like that. Beautiful. So I got a text. 2 seconds. Oh, I'm tired. I also need a shower. Oh my god, I'm getting messages. I got a notification. I'm going to work tomorrow. Sheesh. Okay, so yeah, so this path is going to be the spawn path. Well, it's not really a spawn path, but we want the enemies to spawn outside of the player's view. So the spawn location will be everywhere but in here. So yeah. Spawn location. Okay, now right click the main. Okay, so now we're gonna attach a script to the main function, and we're gonna attach a script. So this is unique. So yeah, okay. So we're going to have a mob scene which is of type packed scene, I guess. So let's have this mob scene here work. And this is going to be something called a packed Oh, is this how we can define types? Oh, so now, so like this, we can say what kind of type they need to be. Okay, that's cool. I like that because I like to define my variables to a specific type. But yeah, okay, so this is the pack scene. Oh, and script variables. Ah. Is it because now we can go inside edit? No. How can I go into this? I really want to see where I can do this. Uh, oh, these scripts are saved inside scenes, that's bad. But okay, so oh, so on the top of main, so main.gd we have the mob scene. Okay, see, I see. Ah, so this is where I define. I looked at the bottom. Okay, I'm an idiot. Okay, that's cool. So here we have the mob scene, and we can just drag and drop the mob right here. Yay, that's cool. So that's nice. So let me just close these for a second. I want to make a new folder for the scripts, and I'm just going to take and drag and drop them inside here. I think that's the best way to do it. Instead of having them all around. Okay, cool. So will it stop complaining? Okay, cool. Yeah. One error. Apparently the deltas you never use in physics. Shut the fuck up. Okay. So now since we have dragged the main here, we can add a timer node which will count the time, I guess, of the main, and this is going to be the mob timer, and the wait time is going to be half a second. Okay, so that's cool, and it will just start on by itself. So if you go into the node, it will have an event called timeout, which is probably where the time will be, where we can run a function which will do some coding. So we can connect it to the main, which has a script attached, which will make. Okay, this is all clicking for me right now. I'm cracking 90s, and now we just need to initiate it, instantiate it. Blah. So yeah, first let's try and instantiate, and by that we go to the mob scene and we just say dot instantiate. Cool. And then we just define the spawn location. And there's something called get node. And oh, and this is how we can get access to every single object in the view. And since I do like the fact that the scripting is integrated, so we can just get access to values of runtime. And I had a typo in spawn path location. So let's see how fancy this is. So if I change this name, will it change automatically? Ah, no. Could be cool. Well, Then we can get the node, and now we can just take the mob spawn location, and there's this called progress ratio. Gives, and it is given a random offset. Let me see. Process ratio. Okay, give it a random offset. So what is so buffer and which is what the path follow knows expects. 0 is the start of the path. 1 is the end of the path. The path we have set around the isn't the problem that we can't use the progress ratio because the reason why we can use the progress ratio is because we haven't defined what type of objects, type of node we are using. So we can't just call the progress ratio. Yeah, that makes sense. But what if we do this and say it can be a path 3D like this? Will it then work? What? It seems it just does it. I am not completely sure. It doesn't give me an error. I'll just run with it. And then we can have the player position. And we can just reference it by using the $. And we can get the player and get his position. And then we take the mob, which has the function initialize. What do I need to do to get the real highlighting? I don't know. So we add child and we do the mob. I mean, it will probably work, you know, but this is kind of messy in a sense, you know. Because yeah, it's a packed scene, but well, it is how it is. I'll just guess that it will work how it's intended to be, unless we make a typo. Yeah, I made a typo. So initialize a vector and direction between the target are aligned. So the start position is equals to I mean, this won't do a thing, I'm pretty sure. But I'm just going to anyway. It will be funny if it just worked. But yeah, I can see this. Yeah. So why won't you work? So the reason for that is because when we use the map, the reason it doesn't know what to do from the lookout from position is because we have the start position and the play position. Maybe they are equals to each other, which is bad. Yeah. So I don't know what this wants from me. The best thing I can come up with is that if not start position is equals to the play position, it probably wants one of them. Oh, it doesn't know what start position is. Start position is different from the player position. The player position works fine, but the start position doesn't. So how do we define the start position exactly? Um, well, it's probably because the spawn location node didn't work as intended, which sucks. So let's see what is happening right now. Yeah, so this is the progress ratio, right? Oh, so this is the points where it will spawn in. And it's called progress ratio. And the progress ratio will change this position of the path follow. So isn't the problem that yeah, I just need to say dot position, right? Because what I put in initialize was just the data for this entity, but I forgot to add in the position. So this will probably be fixed now. I just messed up. And it still didn't work. So why is that? Well, let's go look at the errors. A valid call, non-existent function, initialize in base, character 3D. So mob initialize. Oh. Okay, let's try again. Yay. Woohoo! Okay, cool. So that kinda worked, but yeah, this looks kinda messy. So this does work intended. The intention is that no matter what, the velocity will just go as intended. But as clearly seen right here, it will stop when it gets collided with something. So that's not what's supposed to happen. I don't know if because I have some settings which does it, but it don't really matter. No, I'm not going to use Unreal. I don't have enough space for it. It's too big for me. And also, I want to learn Godot. I don't need all these AAA. I don't need all these AAA studio graphics and tools. I just want to chill and make small games. Like, I know you can do that with Unreal, but Unreal is more intended to be more professional, right? Like maybe you just an Unreal Engine wannabe and that's fine if you like it. But I don't get what's wrong with me using Godot. Like you could say the same with Unity. Like why use Unity if you can use Unreal because Unreal has better graphics? Well, it's not about graphics, it's about style and gameplay. Mostly gameplay. Gameplay is the most important, in my opinion. Oh shit, there's a storm outside. Oh, I'm going to freeze. Do I have the heater turned on? Yes, I have. It's just a bit cold. I need to turn it up a little bit. I'll also chill soon. Okay. So I have spawned monsters. I just need to squash them, and they need to be able to kill the player. Oh, layer matrices. Oh, okay. Then I can have a layer matrix and make it so the enemies can't touch each other. That's pretty good. And I can make a signal emitted when the player jumped on the mud, so the signal squashed. Okay, cool. I'll probably do this tomorrow. I want to chill for now, and I'm halfway through this little content tutorial. But as of right now, Godot is okay. Like it seems like a pretty good engine compared for its size. Also, it's only 111 megabytes, I think, and it's pretty simple. So yeah, it would probably take me some time to get used to the format, but it's pretty good so far. But I will probably, maybe it's just because I have 7 years of experience in Unity, but I just think the Unity format makes more sense for a more natural state, but I think it's because maybe Godot is more data oriented than object oriented for these nodes types. But yeah, I've been streaming for 2.5 hours, just talking to mostly myself. There has been a few people in chat, like 1, 2, 3, 4, 5 different people. That's huge. So yeah, I also got 4 likes in this live stream. That's pretty cool. I will. I'll probably make a devlog about this Godot little adventure, and when I finish this tutorial, and then I'll try making a little video, a little game using Godot, and by that end experience, I'll maybe decide, yo, what should I use, Godot or Unity? Godot is faster to run than Unity, so it feels a lot smoother, especially with compilation time. In Unity, when I Control S The scripts take sometimes quite a bit of time to compile, but I just also really love the customization on Unity. It just feels more natural, you know? But yeah, but it doesn't really matter. But for now, the tools I've seen, they're pretty useful. I do want to check on how I will make an inventory. I will try to see if I can remake my inventory system in Godot. I think that would be probably cool. But also, since if I'm going to do like YouTube seriously, it would probably make sense if I used Unity because it has a broader market and more people use Unity. And I think this whole Unity drama will probably it'll probably be over soon because Unity is probably gonna revert the decision or something or make a compromise with the developers since there's been such a huge outrage. No matter what, Unity is kind of shady, but yeah, for me, I don't really care because I like the software. I try to detach it. I just don't want Unity to fuck himself over too much, so I can make my games however I want. So yeah, I think that's going to be it for today. It's also, yeah, 8:30 p.m. because it's 12:30. So I'm probably gonna have a shower and head to bed because I have university tomorrow. I need to study, and yeah, well, tomorrow's going to be a chill day because we're only gonna do programming. I can already do programming, so I'm probably just gonna help my classmates, and then I have work tomorrow. I just don't hope it will rain all night. I hate rain. But yeah. Oh, I also need to make the P0 project. I need to with my study group. Well, it'll happen. But yeah, I've been also kind of mumbling. I don't have a lot of energy today, but that's mostly because I went out bouldering with some of my friends yesterday, and yeah, it's it's I'm just exhausted. But yeah, it's going to be fine. I'll play around with Godot some more tomorrow. No, not tomorrow because I got work. Shit, because my plan is that when I use Godot, I will stream it, and same with Unity. I think it would be kind of cool to make game development on a live stream and check out if people want to see it. But yeah, I don't really know. But yeah, I'll end the stream now. So goodbye, guys. Yeah, I'll maybe we'll see each other again another time. Goodbye.